Okay, this is the project for the Team 19, predict flu outbreak using Twitter data. Our team number including Shi, Summit, and Yi. So for the overview of our study, first, accurate and timely disease forecasting of the flu outbreak is of great importance. And the traditional method used in the medical practice normally have timely 1 to 2 weeks delay. That means the prediction is too late. And our project focus on using Twitter data to predict the flu outbreak. The method we used, generally we use a series of models, and they work in a pipeline. First, we use a classification model to classify whether a Twitter is flu related or not. There's a second classification model, which is used to classify whether a flu-related tweet is about flu awareness or flu infection. And these two classification models are used as the filtering. The third model we use is the prediction model to predict the probability of the flu outbreak in the next weeks. And we also use the real-time tweet classification and the dashboard. And this is the diagram for our overall method. So we can see their historical Twitter data with labels, and we use this data as the training data to extract our features and model training for both classifiers. And also we have the prediction model, and for the real-time classification, we have the real-time Twitter data, and the same. We do the feature extraction and go through the two classification models and then the prediction model. And finally, we will use the Elasticsearch database and then dashboard. For data collection, so open source data set can provide us with the Twitter ID together with the labels, and we use the TweetPy to get the historical Twitter data. And for the medical data, we use the CDC illness data. And for the real-time public Twitter data, we use the Twitter4j. For the Twitter classifiers, there are 3 steps for the feature construction. Step 1 is the tokenize, and step 2 is the filter, and step 3 is to transfer to the feature vector. And in order to improve the accuracy for the feature construction, we also filter the tokens using the Atom keywords. And for the modeling and the evaluation, so we use the binary logistic regression for both classifiers, and we use the k-fold cross-validation to find the best model as our final solution. And for our final model, the outsample AUC are 0.65 and 0.82 respectively. And here we can see that why only the first classifier is not enough. That is because that some of the flu-related tweets are only about flu awareness, but not real flu infection. In that way, if we can use the real flu infection tweets, the prediction accuracy should be much higher because the flu infection tweets has higher correlation with the real CDC ILL illness data. And next part will be the prediction. So for the prediction model, first, for each week, we record the fraction of tweets which are about real flu infection, as well as about the CDC illness data. And the model we use is a linear regression model for the prediction. And the training set is constructed as a rolling basis. So for the training data, we use data for 175 continuous weeks and divided them into 5 parts, and then use the rolling forward cross-validation method to test for the testing and selecting the model. And the best model we have here is listed here, and also the rolling forward cross-validation result is shown in the figure. The next part, after the three models, is the real-time tweet classification using the Spark. So the Spark streaming pipeline performed below task. First is to using the Twitter 4J streaming API to get the public Twitter data, and then based on our previously constructed Twitter classification classification model and a prediction model, and we apply this model and then save our final list of tweets in the Elasticsearch database. And then it will be the dashboard, and that will be our future works. As we can see that for a given location, we want to have the ability to view the current tweet, which are classified in real time as infection from our classification model. And also we want to do an outbreak forecasting for the current weeks as well as the next weeks. And also we want to have a two-dimensional linear plot of the percentage of the flu cases based on the medical data, CDC data, and comparing with our flu outbreak prediction model. So for the conclusion and the future works, we have built a flu prediction system based on the real-time Twitter data and a series of models in a pipeline. And for the future works, what we can do to improve is like we can try to get more up-to-date Twitter data and medical illness data. In that way, we can have more updated classification models and have more accuracy. And another thing is to try to use more both historical medical data, and historical Twitter data to predict the flu outbreak. And based on our study and based on the implementation of this real-time system and successfully, we believe that this idea can be extended to other domains in healthcare. In that way, lower the cost of the disease research.